Hello and welcome to the wonders of science and maths. I'm your host, and today we're going to be going through finding the derivative. This is a fundamental part of differential calculus, and it will be mentioned in both Year 11 and Year 12 maths methods. So it's very important that we go through it. We're going to start off going through first principles, and then we're going to go through the other rules, such as the chain, product, and quotient rule, to enable us to find the derivative in many circumstances, with many equations. Let's start off with first principles. So we have the equation, if my pen wants to write, f of x, that's a really bad x, equals 2x squared plus 1. Okay, fairly simple equation because it's easier to demonstrate first principles with more simple equations. In this case, first principles is going to follow the general formula f dash x. Now that dash there, I'll circle it. Don't circle it when you're writing, I'm just circling it to show you. That represents that we're finding the derivative of the equation, okay? The first derivative. If we're finding the second derivative, which we'll go through later, then it will be a double dash, okay? Like pig ears or what do you call them? Quotation marks in English, that kind of symbol. Okay, anyway, f of x equals limit as h approaches 0. You might not be familiar with what that means, but we'll go through that very soon. As h approaches 0, okay, f of x plus h minus f of x over h. So what does that mean? How is this applied in this circumstance? So basically, how we're going to apply this is we're going to have what's happening to x in this equation up the top, the original equation. We're going to do that first to x plus h, from which we shall subtract this original equation f of x, and that will be the numerator for our fraction with denominator h. So let's go through that. We're going to have 2 brackets x plus h squared plus 1, because of that's what's happening to x in this top equation, minus brackets very important here so you don't get the signs mixed up, 2x squared plus 1. Okay, that's the original equation here, fx over h. Okay, let's keep the limit here. I always forget to write that. As h approaches 0. All right, so we'll make that a bit smaller to give us more room. What we're going to do here is we're going to simplify the numerator. Now, a lot of teachers will tell you not to do this. What I like to do, especially in test conditions, to save time, is I write just the numerator. I simplify just the numerator. I know it's improper. I know it puts you at risk of forgetting that it's a fraction and forgetting to re-add the denominator, but it saves so much time. So we'll do that now. We'll draw a divider here. The numerator, 2x plus h squared plus 1 minus 2x squared plus 1. This simplifies to 2x squared plus 4xh plus 2h squared plus 1 minus 2x squared. We're going to run out of space. Excuse the terrible x's here. My pen's very annoying. Minus 1. Now, this is the numerator, okay? As you can see, we're going to have a few things that are going to cancel out. The 1's cancel out, minus and positive. The 2x squared cancels out, minus and positive, leaving us with 4xh plus 2h squared over h. Remember, it's a fraction, easy to forget, and that's a risk of using this method of solving just the numerator by itself. It's easy to forget that it's a fraction, okay, over h. Now, again, you're going to see immediately we have some more simplifying we can do. The h's cancel out. H cancels out, h cancels out, 1h cancels out. This leaves us with limit. This is where the limit comes in. As h approaches 0, 4x plus 2h over nothing. This h cancels out, became a 1. Okay, 4x plus 2h. Now, as h approaches 0, this is very important, As h approaches 0, this is basically saying what the equation is going to become as h gets closer and closer to 0. H can never be 0, but to demonstrate the limit of the equation, we're going to substitute h as 0 into this equation, leaving us with 4x. And there you have it. The derivative of 2x squared plus 1 is 4x. Now you might be thinking, this is a simple equation, 2x squared plus 1. And it took so many steps and it took so long to find the derivative. How on earth am I going to do this in a test situation when I have more complex questions? Fortunately, I have good news for you. There is a shortcut. This shortcut is so useful. Honestly, I'll never, ever, ever use first principles unless the question asks me to, because of how useful this shortcut is. Let's use, by comparison, a more complex equation to demonstrate this. We're going to have fx equals 2x cubed plus 14x squared plus 5x plus 3. The way this, I like to call it the shortcut. I'm sure it's got a proper name. I can't remember it right now. We'll refer to it as the shortcut for the purpose of this video, but definitely ask your teacher its proper name. All right. Let's start with constant numbers that don't contain the variable x, like this 3 at the end here. If you see a number, unless it's multiplied by a number that has x, if it's just a constant by itself, we can get rid of it, all right? That disappears, okay? Now, the numbers with x are going to follow this basic sort of formula. Let's say we have ax to the power b. What we're going to do here is we're going to bring b down to the front to have a times by b, so ab x, so multiply the coefficient of x with the power of x, abx to the power, the coefficient b minus 1. So the derivative of ax to the power b is abx to the power b minus 1. Okay? So how do we apply this to our equation above? 2x cubed. Bring the 3 down, multiply it with the 2. 6x, 3 minus 1 squared. 3x squared. That's the derivative of the first term. The second term, 14x squared. We're going to have our plus here. 14x squared. Bring the 2 to the front. 28. 14 times 2. X. 2 minus 1. 1. We don't need to write anything because x to the power 1 is just x. Plus 5x. Bring the 1 down, multiply it with the 5. 5. X to the power 0, because 1 minus 1 is 0, is 1. So we're going to have just 5 here. That just stays as that constant. So the derivative of fx equals 2x cubed plus 14x squared plus 5x plus 3. The derivative is 6x squared plus 28x plus 5. Easy, right? Easy. This is very easy to apply to this kind of equation where we've got a lot of terms. Looks daunting. We use this easy method, not a problem. Easy marks in a test, right? This is where things start getting a little bit more complicated, okay? We're going to go through the product rule. This is applicable to equations where we have terms involving x multiplied with others involving x. So, for example, let's have 14x squared times by, in brackets, 6x Yeah, plus 2. All right. Now, this looks confusing. Your first instinct would probably be to bring the 2 down, multiply it by the 14, times it by 6, something like that. That would be incorrect. I make that mistake all the time. We have to use something called the product rule here. Now, I'm not going to explain this rule using letters A, B, and all that. I'm just going to show you with these numbers because I don't want to overcomplicate things, okay? I'll explain how it works. What we're going to do is we're going to label this term here. We're going to label that U. I know term is not the correct word to describe this. I know, I'm just going to say it for now. We're going to label this in brackets here V, okay? And we're going to have U equals, I like to make a little key, one corner of my page. I can just keep referring back to it. I find it very, very easy, makes things nice and tidy, makes my working out easy, all right? U is equal to 14x squared. And then we have to find U dash, that's going to be the derivative of U. And we use the rule we just went through a second ago. Bring the 2 down, 28x, okay? To the power 1, x is just x. Now V equals 6x plus 2. Derivative of V is going to equal 6. Get rid of the 2 because it's a constant. 1 comes down, multiplies with the 6. 1 minus 1 is 0. You just get 6. Okay? This is where it gets interesting. What we're going to do with this key that we've made is we're going to apply it to the formula U dash V plus U V dash. Okay? So we're going to take U dash from our key here. I'll put a square around the key to separate it. We're going to take U dash 28x and we're going to multiply it with V. So 28x times 6x plus 2. Yep. And we're going to add that to U times V dash. So 6 times 14 is 84. Definitely just did that in my head, didn't use a calculator, 100%. 84x squared, okay? Like that. Excuse the messy 8. Now we'll simplify. Going to have 168x squared plus 56x plus 84x squared. Combine like terms. We're going to get 252x squared plus 56x. So the derivative of 14x squared times 6x plus 2 is 252x squared plus 56x. It's as easy as that. Now, you may be thinking, that's all very well. We have an equation where we're multiplying different things that are multiplied by x. This is the thing we use. What about when we're dividing? What do we use then? How are we going to figure it out? Well, we're going to use the quotient rule. It's a similar concept, slightly different, okay? I'll go through it in the same way I went through the other one. Let's use the equation x squared over 2x plus 3. Again, not overly complicated, but you're probably thinking, it doesn't look hard, but it's a new format. How do I find the derivative of this? Well, you're right, it's not overly hard. I'll show you how we do it. In this case, the numerator is going to be u, x squared. U dash, derivative of u, you guessed it, 2x. The denominator, v, 2x plus 3. What's the derivative of v? 2. Okay? Now this time we're not going to have u dash v plus uv dash. This time we're going to have, I'll move this over. This time we're going to have u dash v minus uv dash over v squared. Okay, so a little bit more complex, but nonetheless, it's easy enough if you just substitute these in the correct way. So we're going to go through that now. U dash v, 2x times 2x plus 3 minus 2 times x squared, 2x squared, over v squared, just put it in brackets, 2x plus 3 squared. No need to expand those brackets, okay? When we simplify that, we get 2x squared. Sorry, mistake. 4x squared plus 6x minus 2x squared. All right, 4x squared minus 2x squared going to give us, this is just a numerator, by the way. I'm getting into my old habits. We'll put it over the denominator to prevent confusion this time because it's a bit more of a tricky question than before. Okay. All right. These cancel. We're going to have 2x squared plus 6x over 2x plus 3 squared. Now, here we can see we have a little bit of simplifying we can do. We're going to take 2x as a common factor. And then in the bracket, we're going to have x plus 3 over 2x plus 3 squared. Now, I would leave it like that. Okay, this is the final answer. Derivative. Most tests, at least in South Australia where I'm from, will not require you to simplify beyond this point. So I would leave my answer like that. So as we can see, the derivative of x squared over 2x plus 3 is 2x times x plus 3 over 2x plus 3 squared. That's the quotient rule. That's the hardest rule of them all. So that's the hard part done, and that wasn't that hard, right? Easy. Now, I realize as I was doing that I did skip ahead of myself, and there's one more of these simpler rules that we didn't go through that I think we need to go through. I think it's quite important because this catches a lot of people out. They forget that this rule exists and they try and solve it differently and it doesn't work, okay? This is called the chain rule. This is used when we have an equation such as the following. Fx is equal to 3, then in brackets, x squared plus 5. My pen is giving up on me at the moment, sorry. Squared. So we've got brackets containing x. The whole bracket is squared. What do? Do we expand the bracket? Well, we could expand the bracket, but that would be time consuming. And in a test, time is marks. You need to save all the time you can on each mark, especially in year 12. That's one thing I noticed jumping up from year 11 to year 12. A lot less time per mark in the test. Okay, I wasn't quite prepared for that. Caught me off guard. So this rule is going to help you save time. This is called the chain rule. So what we basically do, same as when we were finding the derivative before with our shortcut, we bring the 2, that's the exponent, over and multiply it with the 3 to get 6. And then keep the bracket the same, x squared plus 5. 2 minus 1 is 1. So this bracket would have the power 1, but we don't need to write it because power 1 is just whatever the base is. But say if we had cubed instead, then the power of the bracket would be whatever the original exponent was minus 1. So if it was cubed, it would be squared. Okay. Now we don't stop here though. That would be a big mistake. We then have to multiply this with the derivative of what's inside the bracket. So in this case, 2x. All right. So then we're going to have 6 times 2, 12x times brackets, x squared plus 5. See here, we've multiplied this and we've multiplied that. And that's going to be your final answer for that. So that's not too complicated. I forgot to go through it earlier. That's why I did it at the end, a bit of a postscript. But that's a chain rule. Exponent multiplied with the 3 here times the derivative of what's inside the brackets. And you get your derivative, f-x. So I hope this video has been of help to some of you. This is the first video on the channel, so I understand it's a bit rusty. I need to get a better pen for a start. But what this channel is going to be is basically little tutorials like this with maths and also science. Going to be doing a lot of biology stuff, a lot of chemistry stuff, maybe a little bit of basic physics. And also I'd like to have just little videos, say, if I see something interesting online I want to go through, recent advancements, science news, new discoveries, historical science things, even just history. My main passions are science and maths, but I love history too. So although this channel is called The Wonders of Science and Maths, there might be a few little history videos. It's just going to be pretty random stuff, academic stuff, tutorials, and yeah, whatever videos. We'll see how we go. So if you're interested in that kind of stuff, subscribe. If you want, or if you think it's a load of codswallop, don't subscribe. Yeah, I hope this helped. And I think the next video will be how to find the derivative of natural logs and e, which is pretty simple, same stuff, apply it to e. We'll go through it. Okay, have a good day, and thanks for watching.